Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student, this is Dr. Ali El-Moursy, and we are recording the lecture for microprocessor class. This is lecture number 18. Lecture number 18, talking about the conditional branches. So I'm going to share with you right now my screen in order to discuss the slides. So right now we are in slide number 18. This it's 28. This is lecture 18, and we are on slide 28. This is related to conditional branch or conditional jump instructions. In the last two lectures, 1701, 1702, we actually covered the unconditional branch or the unconditional jump instructions, and also the call and return instructions. Those two category or those two instructions, either the jump instruction or the call or the return, the three instructions that we learn, with all of their addressing modes, with all of their flavors, they are under the condition or under the category of the unconditional branch instruction. If we go back very early in the chapter, going back to the agenda of the chapter, so we will find the chapter is talking about two categories of instructions: the unconditional control flow instructions, including the jump and the subroutine handling instructions, and the second category is the conditional jump instructions. Conditional jump instructions are a little bit tough. They are difficult because actually they require multiple instructions to cooperate together in order to perform the needed or the desired operation. What's common between the unconditional branch instruction is that those instructions are jumping unconditionally. So whether you are using jump instruction or you are using the call instruction or the return instruction, the three instructions that we have learned are unconditional jump. That means when the microprocessor encounter one of them, when he fetch the code in order to execute any of them, that means the direction of the execution for the program flow will definitely change. The direction will definitely change. So the IP will not go sequentially or go to the next instruction anymore. These are the unconditional control flow instructions. Today we want to talk about the different category of jump or conditional jump instructions. As their name indicates, the jump is being performed conditionally. The jump is being performed conditionally. The major instruction in this category is the conditional jump instruction. So let's go back here to slide number 28 and see what is the conditional jump instruction. There, the conditional jump instruction is an instruction that indicates the jump will be performed conditionally. That means whether the program will change the flow of the execution or will continue in the original flow, this is not a final decision. It depends on some condition. It depends on some condition. To motivate using those instructions, why we are learning conditional jump instruction, we will take a very simple example. Our example here contains the very one of the control flow or one of the paradigms that we are using, or one of the directives that we are using in high level language, which is the for loops. In high level language, as we will see inshallah, in maybe not in this lecture, maybe in the next lecture, we will see that the high level language needs to control the flow of the program execution through four different types of controls. In order to do a real programming, you have to have kind of a decision making instructions. The flow of the execution of the program for a real program that actually have some logic, the program that is actually have some thinking, okay, requires that you may uh, you have to take some decision whether you will continue in the flow of the instructions you are executing, or you may change this flow. As an example, one of those examples that we want to that we will learn actually thoroughly is the for loops. All of us know the for loop. For loop is actually means I have some body of the code that I need to execute it for a certain number of iterations. So for instance, I want to get collectively the total number of my grades in all of my classes. So that means in order to do that, I have to go into a for loop aggregating the grades of all of my classes. So I have to add the different grades in order to get the total number of my grades. Okay, so that means I may need here a for loop, okay, in order, so for the different items that I'm graded for, I need to do a for loop. If I have 10 items for my grade, I will have a for loop, and this for loop consists of an index for the for loop, and the iteration of the for loop will be done 10 times. Each time I wanted to execute a routine of my code, and I will repeat this a number of iterations. Time. Can we, by our knowledge of the jump instruction, can we perform as an example the for loop? Unfortunately, the answer is no. And the example shown here in slide 29 is actually proving that. Assuming that I have to do this simple code that you can see here. I want to keep incrementing some values, okay, keep adding some array elements in, I have an array and I want to keep accumulating the values of that array on top of each other. Can I use the unconditional jump here? Let's see. So here I am loading the values of the index. I'm populating the bx and cx, and I'm start reading the values from the memory into ax. I keeps adding the value cx into ax, and I move the data from ax to the memory, and I increment or adding to bx twice, and then I will have a jump. Jump here is actually supposed to make my loop iterations. So jump will make me jump back to the first instruction. But is this a healthy for loop? The answer is no, because actually this jump is unconditional, means every time I will reach to the jump, I will go and jump to this location. So this is what we call an infinite loop. Okay, the code will keep spinning uh, on himself or on top of the loops on top of each other endlessly. So in that scenario, I cannot use the jump instruction. I need what we call the conditional code or the conditional jump instruction. Uh, so what is the conditional jump? Let us go back to our board in order to explain how can I or what is the story of this conditional jump. So today we are describing a new function called the conditional jump. This is actually not only one function or one instruction. This is a group of instructions. Okay? So, first of all, we wanted to understand the concept of the conditional jump. So, we will symbolize this. It's not only one function, or it's not only one instruction, it is a group of instructions. Here we are discussing the conditional jump. In our assembly, the conditional jump is called J instruction, and as we mentioned, it is a group of instructions. It's not only one, it is a set of instructions. So, conditional jump instructions are jumping based on some condition. Based on some condition. The conditional jump instruction will check the condition. Check the condition. So we have what's called the condition for the jump. So we need to understand what's the condition of the jump and what's the action the jump will take if this condition is satisfied. The condition evaluation or checking will be the result of this evaluation or checking of the condition will be one of two things. Either the condition will be evaluated as true, or it will be evaluated as false. If I'm checking for some condition, the condition could be either true or false. Conditional jump instruction will jump if the condition is true and will not jump if the condition is false. So that means in the code I will have actually two directions and I will go into one of them. Okay, so if I am calling the instruction right after the conditional jump, I will label this the instruction B. And the conditional jump takes one operand, which is the target of the jump, as we learned before. If any jump has a target, where to go. But now, this is not an absolute or unconditional jump. This is conditional jump, which means, so this code means, if the condition is evaluated true, means the jump will perform. Jump will perform means I will go to code at label A. Okay, this is the first direction. The second direction, if the condition evaluated as false, jump will not perform. That means I will continue to the instruction B after jump. If I have two directions to go, if the condition evaluated true, I will jump. If the condition is evaluated to be false, I will not jump. That's why it's called a conditional jump. If we have to clearly understand the behavior of the conditional jump instruction. We did not yet talk about what is this condition. This condition could be many things, different things. Okay, we first want to understand how the jump is working. Jump will send me to one of two options of two directions. If the condition is true, jump will be performed. I will jump to the location or the instruction that is labeled with A. If not, there is no jump will be performed, and I will continue in the regular flow. So accordingly, if the condition of the jump is evaluated to be true, so the next IP will have the value A. If the jump is not true, the next IP will be B. Okay? We need to understand this concept very well before we go and proceed with knowing the different types of conditions for the conditional jump. We have to first know how the conditional jump works. Okay? Actually, conditional jump is actually at least composed of many things. Okay? It involves other things. So before I call the jump, I have to make sure that I know which condition to be checked. If the condition evaluated true, I will go to A. If the condition is evaluated false, I will go to B. Okay? So let's go back to our slides and let us see the different conditions that we have. I will just, okay, so let's go back to our slides in order to see the conditions that we have. So this is actually the conditional instruction, and we need to indicate something. Now, the conditional jump instruction is based on some condition, and this condition is actually will be something out of a set of instructions or a set of conditions. What are those conditions? Here is the set. So number 34 show me the different conditions that I can check in order to check whether I can jump or not. Before we go into those different conditions for the jump, we want to learn something very important. All the conditional jump instructions, actually what we can see here in this table is the list of almost all permissible conditional jump instructions. So as you can see here, I don't have only one instruction. I have pool of instructions for the conditional jump. Okay, I have something called jump if above, JA, jump if below or equal, JBE, jump if above or equal, JE, jump if below, jump if equal or zero, jump if not equal or not zero, jump if S sign, jump if not sign, jump overflow, jump not overflow, jump greater, not greater, or greater or equal, less, and jump if conditional for the jump if not a. Okay, so it is a set of instructions. From this set of instructions, you can actually recognize or realize that what are the conditions that the conditional jump work through. And here we want to go back to visit what? To visit the status register. All the conditions that the conditional jump are looking for are based on the flags in the status register. So I have in the status register, we wanted to review the flags of the status register. We have flag for the overflow, or OF. We have flag for the sign, or SF. Flag for the zero, ZF. Flag for the carry, اللي هو CF. Those we can say this is actually the overflow, the sign, the zero, the carry. How many of those? 1, 2, 3, 4. Those 4 flags are what the conditional jump instructions rely on in order to check the condition. However, the condition could be different things. The condition could be either the value of one of those flags, okay, direct value of those flags, or could be a combination between those 4 flags. So here we are checking 4 flags. 4 flags are all what we care about for the conditional jump. Okay, those 4 flags are the C, the carry flag, the zero flag, the sign flag, and the overflow flag. You can see here in this table that all the conditional jump instructions are checking either the value of the flag as it is, or its opposite, or combination of those flags. We will not go into the details of which flag is being checked for each of those conditional jump instructions. However, what we want to understand very well is what are the different conditional jump instructions. Okay, so let's check the first flag. I will check with the easiest one. The first conditional jump instruction is JE or JZ. This conditional jump instruction is checking the condition whether the zero flag is 1 or not. So if the zero flag is 1, means the condition is true, means the jump will be executed. If the zero flag is not equals to 0, it equals to 1, not equals to 1, it's equal to 0, that means the condition is not satisfied and actually the jump will not be executed. Each of the conditions, jump instructions, exist by itself and by its counter. That means I have jump if equal or jump if z, and also jump if not equal or jump if nz. Okay, so I have all pairs of conditional instructions, jz and jnz. Okay, similarly I have jc or jnc. I have also js and jns, jo for overflow and jno. Okay, so those jump instructions, those conditional jump instructions are actually checking the flags themselves. We have 4 flags, so I have jump NC or jump conditional if the CF equals to 0, and the opposite. So I have actually 8 of those instructions. Jump for conditional flag equals to 0 and equals to 1, zero flag equals to 0 or 1, sign flag equals to 0 or 1, overflow flag equals to 0 or 1. Okay, and those are the easy ones. Those are the kind of the pretty straightforward one. There are other conditional jump instructions. Those instructions like jump if above, jump if below or equal, okay? Jump if greater, jump if less, jump if less or equal. Those instructions are not only checking one of the flags, they are actually combining two or more flags in order to study or to discuss or to know whether a condition is true or false. Okay. Uh, this is, by the way, just the introduction for those instructions. Right now, we know we need to understand more about those instructions. So, let me just go back to our board here. Okay. So, we just discussed the conditional jump instruction and what's the action of the conditional jump instruction and the different conditions that we have the conditional jump. Now, we want to go and take one of the examples. Okay, we will take the example for the jump if zero. Jump if zero will jump if the zero flag equals to 1. The condition for this conditional jump instruction is that the zero flag should be 1. Okay? That means this instruction will jump if the zero flag equals to 1. Will not jump if the flag is not equal to 1 or equals to 0. Okay? Now, that means the conditional jump instruction cannot be performed alone because you have to have some instruction before the conditional jump instruction. Its mission is to update status register flags, the 4 flags that we have talked about: overflow, zero flag, the carry flag, well, the sign flag. Those 4 flags should be updated in the status register before I execute the conditional jump. Because conditional jump will be relying heavily on the values of those flags. That's why conditional jump instruction never used alone. They have to be used with another instruction. Okay, usually we there is a one instruction that is always associated with the conditional jump instruction, and this instruction is called. Let me just put some bars here. This instruction is called compare instruction, CMP. So right now we need to learn a new instruction called what? Called compare instruction. What is the compare instruction? Compare instruction is an instruction that is identical to the sub instruction. Do you still remember the sub instruction from the part 1 of chapter 4? Sub instruction is subtracting to either memory location with register or register with register or register with immediate. It's an arithmetic operation that's doing subtraction. However, there is only one difference between the compare and the sub. Subtract is supposed to subtract, like for instance, let me just write here if I write sub ax comma bx, this instruction will do what? Will subtract the ax minus the bx and put the result frame in the ax. And it will also update the status register. While if I use the compare CMP instruction, CMP instruction AX comma BX will subtract AX minus BX and will not put the result anywhere. It will simply throw the result in the garbage. So AX will not be modified based on the compare instruction, but it will help me to update the status register. Okay, both the compare instruction and the subtract instruction are doing subtraction. But the purpose of subtract is to get the answer of the subtraction. While in compare, I'm comparing to do what? Just to update those 4 flags in order to have a useful information about the comparison between the register X and the register BX. Okay? Right. Now, how can I use this instruction, okay, those 2 pairs of instructions to have a conditional execution? Okay, this is actually send us to another subject, which is the utilization of those instructions. So right now we learn the following. I have always in my code to put compare followed. If I have to compare, then jump conditional. I have here the target. Okay, if the condition is equals to true, and I have following the conditional jump instruction the next instruction. Okay, and I have to go to this if the condition is false. This is the typical usage of the conditional jump instruction with the compare. First, I compare between registers, and based on this comparison, those bits will be updated, and I have here to jump conditionally. Okay, if the condition is true, I will jump. If the condition is false, I will. Okay. All what we have learned here or what we have explained here is kind of a theoretical stuff. Now we want to take this into applications. In order to apply these concepts, we need to move to the 4 paradigms that we have in our high-level language for the decision making. The real beauty or the real advantage of a programming is that you have a decision that you can do. If a condition is happening, you will do blah, 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 blah. If the condition is not happening, you will do something else. This is the decision of things. That's actually discriminate the programming of code from just a calculator. I can give some procedure to a calculator and calculate. If this is straightforward, but if there is a decision, if this is happening, I want to do this instead of that, it means I have here a brain, I have thinking, I have logic. Okay, this logic is actually can be described in an abstract way for 4 paradigms only, high-level language. Okay, so our mission in the next lecture to be how use the components in the assembly, which are the compare instruction with the conditional code instructions, okay, the different flavors of the conditional code instructions, okay, in order to perform one of the 4 operations, the most important operations that we have, which are the if-else statements, for loops, while loops, switch cases. We will learn that, inshallah, in our next lecture, which is lecture number 19. So I will stop here and inshallah I will continue in our next lecture inshallah. Okay. Thank you.